All right, we're going to start PFSense's second part. We just installed it in Lab 1, and we installed everything through virtual machines and VMware Workstation. Now we'll move on through into Lab 2 and our walkthrough regarding it. So just a review from last time, we'll need Windows OS that's completed. We'll need that installation. We'll need our PFSense installation, some networking knowledge, and VMware Workstation, of course. Just a review, we have it in through our NAT, VMNAT, through EM1 on our PFSense, which is given to us DHCP to allow for maximum transportability. So we can take it from school to work to home, desktop, laptop, whatever it may be. Then through EM2, which will be out on VMNet 3 or VNet 3 through DHCP, which PFSense provides us in a server, and a 10.0.0 CIDR 24 to Windows, which will then receive a DHCP address and a 10.0.0 something, probably if you follow the video, starts at 5 on to 254. And that is given us on off EM2 through interface or internet interface, Ethernet interface through Windows. So we'll go ahead and we'll finalize PFSense through a wizard. If you miss the wizard or skip the wizard, I'll show you how to get that back. We'll verify internet access through two different methods. We'll complete action 1 and action 2. Action 1 is you are a firewall network administrator who works for coolparts.com, and management has asked you to stop all web traffic. They're concerned that employees are browsing the internet instead of taking orders for the Coolparts website. So we're going to show details or a walkthrough on how you can block all web traffic. You'll need to be able to detail what ports and what filtering settings are necessary to stop that traffic. So if you are not aware of it already, you need to look up what web traffic works on, what ports web traffic works on. And primarily it's port 80, port 443, and the backup port 8080. Since most web traffic has moved to HTTPS, if you want to verify the first part of this, where you just block regular HTTP traffic, you'll need to find a website that works with just HTTP. That can be a little bit of a challenge, but last week somebody knew of ESPN that still works on HTTP, oddly enough, which is great. Also, CoolSite or coolparts.com is a cPanel hosted domain that doesn't have anything on it. So as far as I know, that will still be HTTP. So you can check that setting there as well. We'll need to use that and set that inside PFSense's firewall rules, which we'll do. All right. Action 2 is you're still a firewall network manager through for coolparts.com. Management has decided that perhaps blocking all web traffic was a mistake. Instead, they've identified the culprit as YouTube, the YouTube website being a time waster. So they want to have a way to use PFSense's firewall software to block YouTube streaming data only. So we'll again need to show our details or walkthrough on how to block that streaming traffic. And we'll need to do some research as to find out what ports YouTube streaming traffic works on, which we'll be able to go through. I don't know it off the top of my head, but I'll show you how you look that up. Additionally, you could look up the same thing for HTTP and HTTP traffic. So let's go ahead and get started. Off our PFSense installation, we'll have our Windows and our PFSense, and we can tell that PFSense is loaded and last logged in times there as well. By the way, I need to point out that it's important that we turn off traffic or turn off our PFSense correctly. You don't power it off by our power off settings, because we don't have VMware tools installed on our PFSense. It's a FreeBSD Linux OS, but did you install it? Did you install VMware tools? You don't have to, but if you did install it, then you can use these menus. This power off, suspend, reset, this is the same as pulling the power button or pulling the power cord. So do you pull power cords or just rip the power from your laptop, pull the battery out, or rip the power cord out from behind your desktop? You don't, right? You gracefully shut it down, or you use a soft reboot. You don't hard shut down or hard reboot, because of the files that can be written in the background that you're not aware of. So don't use these menus unless you plan on using the halt system, number 6. That's the correct way to shut it down. Again, the correct way to reboot it, number 5. If you find that you are trying to make setting changes, go ahead and pull this up full screen, and it's not making those setting changes, or you see errors. I know it's Edge and I know it's terrible, but for the most part, we're okay in it. So our login admin in PFSense, and we'll get this little notice for copyright, blah, blah, blah. And here we are right now. So we see our memory usage is using 15% of 1 gig. Our CPU data will come in shortly. And if you have any sort of notices up here, you'll see some, if you see database failed to write or something like that, it's probably due to a poor shutdown usage. You'll need to keep an eye on your notices. So let's mark all as red. Notice we don't have anything that's showing up right now. To get back to our wizard, because that's what we're going to do, because as we sit right now, we should not have internet traffic. See, we can't reach the web page, so let's go google.com. Can't reach the web page. We don't have internet traffic. If we come down here, we'll be able to see no network access, no internet. Doesn't mean that we don't have network access. To verify that you have network access, look at your adapter, check your network, look at your IP address. You should be in the 10.0.0 subnet. So the default gateway, DHC, and DNS are all 10.0.0.1. Your computer's IP address, 10.0.0.5. And of course, everything else will show up as it is. We will go ahead and finish our setup. Like we talked about before, we'll need to go through and hit System, Setup Wizard. And this is what you see if the first time you log in, if you just completed Lab 1, Lab 2 is this is where you pick up. So we'll complete this. You can learn more about NetGate global support if you like. And we'll use our host name as PFSense domain, local domain, and primary DNS server. Now, since I don't have internet, I'll go ahead and tell you that public DNS servers exist out in the internet. Google's is 8.8.8.8. And there's secondary is 8.8.4.4. Those are Google DNS servers. You can also get them for your local ISP. Comcast or Xfinity's is 75, 75, 75, 75 for the primary, and 75, 75, 76, 76. You'd want to look this up, of course, to find the correct public DNS service for your internet service provider. However, if you want to get into net neutrality and you want to get into privatized browsing, when you make a request to go to a website like coolparts.com, if your router has not seen it in the past, we'll go off with an arbitrary number here, 24 hours, then it will need to reach out to your internet service provider. If they haven't seen it, it'll go to the next one as DNS works through the backbone of the internet till it reaches the 5 or 7 major DNS providers across the United States. Other countries have it differently, but I only know about United States. When you make these requests, your internet service provider can see what websites you go to, so they can sort of form specialized ads, or they can push ads traffic towards your machine or your internet at home. And you may find that to be a tad invasive. Cloudflare uses 1.1.1.1, and that's too many ones. And I believe it's 1.1.2.2. All right, so you can use either or. We're going to go with Google because I think my 1.1.2.2 is wrong. So we'll look that up here in a second. 4.4. And we will override DNS to force these two to be used. And if we happen to be using DHCP point-to-point traffic over WAN, it will also push this over as well. For the most part, you won't have this, but just keep in mind, if you have something like a DSL or a fiber connection that requires PPP OE or PPP point-to-point protocol, then you'll want to use that connection for DNS unless you have other options. So I think I spent too long talking. All right, we'll go back into our wizard, push the next. Local domain PFSense, our servers 8.8.8.8, 8.8.4.4. Our time server, we'll want to use a correct time server. Here in the Houston area, we use GMT-6. So the correct fully qualified time servers, I'll need to go back to my host machine to get that information. Come on. So additionally, we'll also be able to look up Google public DNS, which shows us 8.8.8.8 and 8.4.4.4. If we wanted to use Cloud Flare's DNS, 1.1.1.1, and you can read about what they used there. I thought they had a 1.1.0.0 for a backup, since you typically use 2 DNS providers. We'll look at NTP pool servers. This looks like North America. Here are some servers. So we'll take 0northamericapool.org. And we'll leave it at GMT-6. So it's going to go to this site to pull our information for our time so that our time stays correct across and synced with our Windows time and our firewall time. Additionally, you want to make sure your router, switch, if you have a smart switch, are all set up to the same time. So if you have an intrusion at a certain time, they'll all be synced across it. We'll leave selected DHCP type for our wide area network. That's our interface coming in. The MAC address will stay the same, MTU, MTSS. Static IP we're not touching because we're not going to go static. If we wanted to have a DHCP host name that ISPs may require for that, the PPPoE traffic that we talked about, the point-to-point protocol, and then if we have to block any specific traffic, we can. We'll leave all this alone, and we'll block non-internet routed networks from entering the WAN. That means that traffics that are reserved cannot be coming in to our firewall. And this was already configured at 10.0.0.1 on a subnet mask 24. We're just going through in our LAN set now. Now, it will not let you, I think, let me pass it. That's cool. We're going to leave it as PFSense and admin. Ideally, you would want to change that. So we'll reload now and finish our setup. We'll go back to the PFSense web configurator. It probably will ask us to log in. Now we have a working network traffic. CPU usage is 47. It'll come down here in a little bit. And let's make sure we have internet access now. Now, we have internet access. That's one way we just verified it. We'll verify it a second way by pinging our default gateway. So this says we have traffic up to our PFSense firewall. Now that's not internet traffic, so we need to go past that and we need to ping out google.com. And in fact, we do have internet access at 22, 23 milliseconds. Not too terrible. I am wireless and I am going through a few virtual interfaces, so that's not too terrible for our lab purposes here. All right, so we have internet. We verified that based on our settings earlier. Now we are essentially serving this firewall for the entire company of coolparts.com. This right here is the problem that I'm seeing with some people because they weren't shutting it down. Apparently I did the same thing, and that's okay. This is exactly what I wanted to see. If you have this error, then our shutdown procedures have not been proactive. And that could be for various reasons here. The way to fix that is to update, and it will go through and reinstall any missing files or anything like that. Again, you can look at the settings here. And if we do developmental, that's more of a beta, and we want to stick with stable. So we won't do that because that'll take some time. We'll come back and look at it, and you see how the CPU data takes a while to load. It should be almost instantaneous. So we'll just have to work with this as we go. So we'll start with firewall, rules, and we'll pay attention to our rule sets here. So if we were to create a rule here, choose the interface from which package must come to match this rule. So our interface is going to go into the LAN side, not the WAN side. So we're on the wrong setting here. We can switch it to LAN, and we can set the action to block traffic. All right. When it's blocked, it will drop the packet silently. If it's rejected, it will block it outright and give the user the interaction that the traffic is not working. So we will need to take our destination port range in port 80. Nope, that's HTTPS. Port 80. You can do customs, you can do ranges, but for the most part, we're just going to do one. All right, and we're going to say regular HTTP traffic block. That's our note or our description. All right, it will make our save now. Before I forget, you need to make sure you select your IP address family. Now we're going to do both together because we want to block out HTTP traffic altogether. Again, TCP and UDP can be working on the same, so we're going to set it to ignore both IPv4 and IPv6, as well as TCP and UDP. That's a rejection. We're going to use the LAN interface, IPv4, IPv6, TCP, UDP, and we're going to do port 80, and we're going to call it regular HTTP traffic block. We'll save our settings. The setting has not been applied yet until we apply our changes. All right, and when we come look at our monitor, there are errors loading the rule, could not allocate memory. This line in question reads table files bogs on 6v6, which means that we have that error that I was talking about. The way to fix that is to reload the system or update it. So for our point in time, we're going to reboot. We'll reboot our system. And if you want to check the status of that, you can see it here. And you'll notice that we lost internet traffic. So with the web configurator loaded, we should be able to re-access our website here. No, there we go. Admin, PFSense. We'll go back to firewall rules and take a look at our LAN rules. Because remember, we switched that over. If it's not showing a red X, we need to turn that on. So we'll go back to edit. Instead of reject, let's do block. There, that's what I wanted to show. So we can show all HTTP traffic by taking a little stroll to coolparts.com, which shows we can't access it through http coolparts.com. Same with, for whatever reason, espn.com. Now, as it sits, our lab is technically not over because we can't reach ESPN, but have we blocked all web traffic like Google, which uses HTTP, and we can also go to HTTPS Google, and we have internet traffic. So for the most part, we are still halfway done with our lab. We need to go back and make those changes. So we'll pull up PFSense real quick. And you can do a couple of things from here. We can copy or clone our rule using this guy when I see the tooltip show up. This is cloning it. Or we can go back to firewalls, rules, LAN, and here it is again, 8022 anti-lockout rule. That's for our web traffic to be able to reach here. So we're not really blocking out our access to this website, which is great. So no, it's like a safety net, because technically that should have blocked our HTTP 10 right here. Isn't that nice of PFSense? So we're going to add an action to block through the LAN interface, IPv4 and 6, TCP and UDP. And we'll select the destination HTTPS. We'll call it secure HTTP traffic block. And we'll save our rule. Probably get that same message here. Apply our changes. There it is. Cannot do it because of the memory dump. So right now it did not finish. If you're curious to see if it finished or not, you can go through diagnostics and check or maybe it's status. Monitoring what's being loaded, system processes. It's not what I was looking for. System logs. We got our firewall blocks, and we can look at specific actions that's going on, specific protocols, source IP, destination port. We'll go into captive portal later. We'll deal with IPsec and VPN later. Load balancer we really won't take into effect because we really only have one interface. OpenVPN, again, we'll look at the differences in VPN, IPsec. And there's our time protocol and how our addressing and timing goes from our pool server to out in the internet. Any other settings for our server logs. We'll go back to firewall and just finish up our rules for our LAN interface to finish out our lab. Make sure we do IPv4 and 6, TCP and UDP. And for our destination port range, if you don't see it here, the 8080, the backup HTTP, which I don't see it, we'll need to add it to our custom block, so 8080. And if we wanted to make it a range from 2, we could do 8080 here as well. For the most part, we don't have to worry about that. So instead of regular, we're going to do backup HTTP traffic block. We'll save our set. It won't go through completely. Apply our changes. We'll take a look at the monitor the filter reload. And we can see that it failed here. So it didn't finish. It wrote the changes to our firewall rules because we can see it here, both the backup, secure, and regular. And if you want to move these around, you can. You just drag and drop. Now, I did not set this up correctly because I didn't set it to block. It's allowed right now. So we're going to edit our set, leave this page, and we'll choose from action pass to block, save it, apply our changes. Again, it didn't go through because of our table ruling. And we'll go back, go status or diagnostics, reboot. Rebooting it. Because up until the actual firewall takes place and the process is finished and restore their services back to their original condition, we'll still be able to browse technically. So this would be an unideal firewall at this point because I would have to take it down for every firewall rule change, which means everyone in the building losing internet at the exact same time for a period of a few minutes. May not be inconvenience to one, but when it becomes a building of 500, 5,000, that's a lot of man hours that management would look at and say that's a productivity nightmare. So we can again take a look at our PFSense settings and how it goes and how it works through the system. So we're about 28 minutes in. We're back up. Come back over to our settings. And we have HTTP access to this. Admin PFSense. We have admin access to this. We have web traffic access still. But when we decide to go to using Bing, that's what Edge uses. Aren't I lucky? We're not going to get anything. So the Bing search for the word test is going to return nothing here in a little bit. We can try going back to espn.com, which was our HTTP traffic, which was already previously blocked. And go to www.google.com. And it was not reachable through HTTPS Bing. We'll wait for this to finalize itself, and then we can try loading the Weather Channel or Reddit or Facebook or Netflix or LinkedIn, whatever Edge says we want to go to, but we don't really care about what Edge thinks. Cannot reach HTTPS Google. Cannot reach ESPN on regular HTTP. And weather, HTTP weather can't access. So effectively, we've blocked all internet traffic. What's really cool about this is we didn't block all traffic. So traffic like Windows updates will continue to run. Traffic like the syncing to time servers will continue to run. And if we needed to do external applications that don't operate on 80 or 443 or 8080, will continue to run. So for the most part, business, quote unquote, business can continue to run uh, depending on the application. Time-wasting websites like YouTube is blocked. Time-wasting websites like LinkedIn, uh, Reddit, Imager, they're all blocked effectively at this point in time. You can still set up rules for internal web access to, say, a web server like PFSense or another web application that may be inside your business. So super handy. For the most part, though, in our lab, for our purposes, we've said, oh, that may not be the best course of action. So that's it for step one. We've blocked all internet traffic. And we'll go take a look at step two and just sort of a review of what we have here. Let's go back to firewalls. The lab 3 PFSense finalized setup, where we were the firewall administrator. We work for Cool Parts. Stop all web traffic. We have done that. We showed our details on how we blocked all web traffic, and we needed to figure out what port filter settings were necessary. Done. We have completely finalized that settings. Now it's up to step two, where we need to block all web traffic. Management realized that was a mistake. Instead of that, they want to just block YouTube specifically. We're going to use the firewall only to do this, to block streaming data. And again, we'll need to figure out what that is. Now, there are add-on packages like web filtering software. We'll get into that next lab. So stay tuned for the next lab in our series where we use add-ons to specifically web filter out traffic, not this totalitarian method that we're doing here. So first step is to research YouTube streaming ports. And there's a few places we can find that. Teradek, support Google, Stack Overflow. So we'll see if this community has any luck. It used to be easier to find. I think that's because of Google's takeover. Nope, that's Steam, not Stream. I feel like I should have figured this out better. So I'm on my host machine right now. Trying to look at port listings. Let's Google Wi-Fi. All right, they're listing out ways to do that. So I'll go ahead and stop this recording.